All right, so exponentials. This first set of notes is mostly going to deal with having a base that is a number. The second set, we're going to look at some continuous growth, so that's whenever we have E as our base. So this, I know for sure that you should have done this. Well, you guys were you guys in 8th grade COVID year that we got sent home? Okay, who knows what you should have, and in a normal year, Ms. Ball definitely would have covered y equals a times b to the x. Is that familiar? Math 1, hopefully. You've probably also seen it again because it's in Math 3 if you didn't do it in Math 1. But y equals a times b to the x is an exponential function. In this function, a here is your principal or your starting value. A lot of times we do this with interest, like at bank accounts, so it'd be your starting amount that you put in there. It might be population growth, so that's how much you start with. B is your growth or decay factor. Okay, so if you have exponential growth, it is 1 plus the rate. I should have put right here as a decimal. So if your growth rate is 10%, it would be 0.1. So 1 plus 0.1 is what you would use for that B value. If you have decay, it's going to be 1 minus that rate also as a decimal there. So if we have exponential growth, then we are going to see that this B value here is 1 or larger. If we have decay, it's going to be between 0 and 1. If you have a negative in there, it's a crazy problem that I'm not going to ask you about right now, so you're not going to see that. Okay? So the first thing I want us to do is to be able to just look at an equation and tell what the starting value is and whether it's growth or decay and by what percent. Okay? So specifically, the growth or decay and by what percent is what students typically need a little extra practice with here. But I'm going to write down starting value as well, even though it doesn't really ask for it there. So, if we look at y equals 6,000 times 1.05 to the x power, Maggie, what's the starting value for that? 6,000. Okay? And then, Amanda, is that going to be growth or decay? It is growth. How do we know it's growth? We're looking right here at this number, and it's bigger than 1. Right? So if it's bigger than 1, it's going to be growth. Okay? And our growth rate, to find it, to find the B value, you had to do 1 plus the rate, and then or 1 plus the rate as a decimal, right? So to find the growth rate, we just want the rate. We got to subtract 1, so we do 1.05 minus 1. That's going to give us 0.05. That's our rate, but it's a decimal right now. Rates we typically want to report as percents. What is 0.05 as a percent? 5%. So it'd be a growth rate of 5%. And that works every time. Subtract 1, change it to a percent. It even works with decay. Subtract 1, change it to a percent. Okay? Number 2. This one's a little tricky on that start value. It's a little tricky all around. Start value. Who can tell me? It's not 3. It's not 0. It is 1. Because if I put a 0 right here, all right, if I put a 0 right there, 0 times 3 to anything would still be 0. But if I put a 1 right here, does it change the value of anything? It does not. So the start value there is 1. If the start value is missing, the start value is 1. Okay? Let's see. Mallory, is this one going to be growth or decay? Growth. Okay? And let's see. Reagan, what is the growth rate for this one? $200 is it. So what we're doing here, we take the 3, we subtract the 1, which gives us 2, but that's our decimal, right? Even though there's not a decimal there. So to change it to percent, you got to move that decimal 2 places. So you'll get 200% growth. If you triple something, if you multiply it by 3, it's 200% growth. If you multiply it by 4, it'd be 300% growth. If you double something, it's 100% growth. Okay. Jeremy, what's start value for number 3? Very good. Bo, is it going to be growth or decay? Decay. And Luke, what's the rate? Since we use the word decay, we don't have to put the negative with it. We'll just say 2%. Yeah. So
wouldn't it be 0.2%?
it's going to be 2% because what we're doing here, we can do the same thing. To find the decay rate, you did 1 minus the rate. So if you do 9.98 and subtract 1, so same thing we were doing for growth, right? It gives you negative 0.02. The negative part tells you it's decay, right? So you don't have to write the negative. That tells you that you're dealing with decay instead of growth here. And then that's a decimal, so we need to move that decimal 2 places to change it to a percent. So we'll have 2% for that. Because this number right here is less than 1. So if it's less than 1, you're going to get a negative whenever you subtract 1. 4 is decay, yes. Let's see. Lucian, what's start value for number 4? Good. And Macy here just told me it's decay. Emma, what's the rate?
I said 50%.
Good. 50% is great. This is the only one you can really like a lot of students will say 98% decay right here, which is wrong. They just changed that to a percent. This is the only one you can get away with doing it incorrectly here. But what you're doing is you're doing 1 half minus 1, which gives you negative 1 half. And negative 1 half, of course, is negative 0.5. Move that decimal 2 places, you get 50%.
Could you just think about that as 1 whole minus a half?
Yeah, that'll be fine. Okay, questions here? All right, let's look at some application problems. Okay, investments. Okay, you invest $6,000 in an account earning 5% APR compounded annually. How much money will be in the account in 5 years? So APR stands for annual percentage rate. And so this, when you see APR, and pretty much always, sometimes I forget to put APR. If I say that there's a 5% interest rate and it doesn't say APR, assume it's APR. I've just messed up and not written the problem very well. So this is annual percentage rate, as long as annual matches how often you're compounding here, right? If we have annual percentage rate and we're compounding annually, we're going to use compound interest, but it's going to be a pretty simple formula, okay? So we would, for our equation, we would start with our start value, which is 6,000. And then here for our B value, we're going to do 1 plus the rate as a decimal. What's 5% as a decimal? 0.05. That gives us 1.05. And then we're going to raise it to the number of years, which is 5 right here. Okay, this should be what you've done already. You've done this in Math 1. I'm going to grab my calculator here. Okay, so 6,000 times 1.05 to the 5th. So we get 7,657.68. This is money, so let's round to 2 decimal places. Let's say 69.
I'm confused on like this one plus the 0.05. That's paying. Like I'm confused on what she did right there to get like.
So 5%, if we write it as a decimal, we would have to take this decimal point, it doesn't have one, but it would be right here, and move it backwards 2 places. So 0.05 is the decimal that goes with 5%.
Okay, so why are we adding and not subtracting?
Because this is growth. So when you put your money in a bank account, they're adding that interest to it. We'll see later if we had something like, if our money was, like maybe this was stock market and we were losing 5%. So if it told you that you were losing 5% interest every year, then you would subtract there. So you gotta, if it's growth, you're gonna take 1 and add the rate. If it is decay, if you're losing an amount, then you'll do 1 and subtract the rate.
So the example problem on 1, the very first one, is it growth rate and we subtracted that one?
All right, so right here, all we're doing, it gave us the equation here. We're trying to go backwards and figure out what like the original parts of the problem were. Yeah, so the equation's already given to you. So really, number 1 here matches the situation we have on example, the first example word problem there. So.
Coach Wood.
All right, so now we need to compound monthly. All right. We have, he's just observing.
We don't. We don't.
This morning, I was talking to this boy in my class, and he said his girlfriend was really wild. And I said, sometimes bothers you that your girlfriend has more pictures of me than she
Not wrong.
I said, no, not really. He said, she does have more pictures of me.
And then he's gone. And then he goes. He just wanted the spotlight for
All right. Okay. So, let's talk about what we need to do here whenever we compound monthly. So, same situation. We still have $6,000 in the bank account. We still have 5% annual interest, but this time we're going to compound monthly instead of annually. Okay? So, if these do not match, this is an annual rate. We're compounding monthly. Those do not match. We're going to have to make some adjustments. Okay? So, we need to adjust our rate and our time so that they are also in months. Okay? So, if we have our rate, if it's 5% per year, we've got to divide it by 12 because there's 12 months in a year, right? So I'm going to take my 5% and divide that by 12. So 5 divided by 12 is going to give me 0.416 repeating percent. This is a little tricky here. That's your percent. You got to move your decimal 2 places. That's going to be 0.00416 repeating. You can, if you would like to do it that way. So if you want to take your 5%, change it to 0.05, change it to a decimal first, and then divide by 12, it'll take you straight to 0.00416 repeating. So either way that you're thinking about this, you can do that. So this is that value that we need for our B value. So we'll still have 6,000 right here. We'll do 1.00416 repeating. Okay, so instead of using 5 as our interest rate, we have to use it what's adjusted for the monthly interest rate. Because we were getting 5% per month. If you ever go to a bank and they tell you they're going to give you 5% per month, put all of your money there. You'll be rich soon. So do that. But they're not going to give you 5% per month. They're going to give you, you're probably not even going to get 5% per year on a savings account, but interest rates are going up. So you'll do that here. Your time also has to be in months. So we got 5 years. How many months is that? 60 months. So we've got 60 months here. So you got to adjust your rate and your time. Okay? Yes. Do like my children do and act like you're in a YouTube video, and like when I finish a problem, just go, oh, and run around the room. Hunter lives his life like he's doing a YouTube video. An annoying YouTube video, I should add. Okay, so I just put a bunch. If you only put one, yes. On these problems, because it's money, do me 2 decimal places because it's cents. And I will tell you that at the end. But in general, you don't want to round in the problem because I think if you do this, see how the answer's off? So if you have something repeating, use a bunch. I'm saying 10 or more. I'm not going to give you like a specific number you have to have, but I'd say 10 or more if something is repeating.
If we were to forget to do that, would you count it wrong?
Canvas is going to count it wrong. I might have the goodness in my heart to go back and give you a little bit of credit back, but Canvas will definitely count it wrong. At least 10. At least 10 should get you. Yeah, so whatever repeats, like the 6 is repeating here, put at least 10 6s. That should be good to get you the right answer. And if I'm wrong about that, I'll go back and fix it. But so we got 7,700.15. Since this is money, we'll stop at 2 decimal places on this here. So notice that if we compound more often, even though we have the same amount of money, same interest rate, we get a little more money, right? So it's like, what, about $43 extra that you get here by compounding monthly. Now, that's over 5 years. So it's not like it's a huge deal, but if you have an option between annually and monthly, you would want to choose monthly because you'll end up with a little more money. If you find that you do problems like 1 and 2 here and you get big differences, you've done something wrong. It should be a fairly small amount of money difference. If you got like, what students do wrong for this most of the time is they forget to adjust one of these. So they'll do 1.05 to the 60th power, and they would have $112,000. If you're seeing something that doesn't seem to make sense to you, go back and look at what you've done. You probably messed up. Banks do not give you interest that is that good. Maybe on the stock market, but there's a lot of risk there too. Okay, questions? Okay, here's a good question. Alfredo invests his money in an account that gets 4.8% APR compounded quarterly. How long will it take his money to double? How many quarters are in dollar? I'm sorry. It is 3 months. But what we want to ask ourselves is how many times per year. So since it's 4 times per year, that's what we're going to use to adjust it. So you are correct. It is 3 months. But we want to ask ourselves how many quarters that we're dealing with here. So what's missing about this? I don't know how much money he has. So I need everybody right now to guess how much money you think Alfredo has.
$7.
Okay, so you can use $7. So everybody pick a number. Don't everybody use 7. Okay? All right, so write down start value. Okay? I want everybody to pick a different one. Okay? Okay? So, just because I want to pick something I don't think everybody else picked, I'm going to pick $280. Anybody else have that? That's what you pick now, right? Okay. So, if Alfredo started with $280, okay, then my equation, 280 times, I've got APR's annual, I've got quarters. So what am I going to have to do to that interest rate? Divide by 4. So 4.8 divided by 4 is going to give me 1.2% per quarter, which is 0.012. So I'm going to have 1.012 here. Now that should be the same for everybody because we have the same interest rate. Your 280, you probably have something different. I want you to try it with your own numbers there. And then, you always have to add the 1 to it because this is growth. Yeah, so it is 0.012, but then you have to add the 1 to it when you put it in the equation. Yes. Because in the first example, we had annual interest and we were compounding annually. So we did not have to adjust our rate. Yes. Yeah, anything besides annually, you want to divide by the number of times per year that is. Then, my question is how long, right? So I'm just going to put an X right here. I don't know what that is. But I need to make myself a note right here. This is going to be the number of quarters. Right. So whatever I get for my answer, it's in quarters of a year, not number of years. So I just need to make a mental note of that happening here. Now, I want to know how long it takes for his money to double. So since I have $280, if I double that, I've got $560. Yours is going to be different because you picked a different starting value. Okay? So whatever yours equals, you should have a different number here for your 280. And then you're going to double it, and you're going to put that number over here because we want to see what that equals. Or you could put it over here on the other side. It doesn't matter which side you're at. So I need to solve this equation for x. Miles, what would I do to solve this for x first? We're trying to get... Yes. And to do that, we need to divide. Now, your numbers are different, hopefully. But when everybody just did that, what'd you get? Everybody should have got 2, right? If you didn't get 2, you did it wrong. So it does not matter what amount you start with. You can just make it up. I heard Owen and Valeria fighting over who gets 1 back there, right? 1's a really good number to use because it's really easy, right? So I would also use 1 if I was doing this problem. I would not use 280, but you could. You can make up any amount. It could be, 280. It could be 100. It could be just $1. It can be $7. It doesn't matter. You're going to get to the same thing either way. All right, how do I solve this? Not square root. I got the exponent. How do I get rid of exponent? Or how do I get... What's the inverse of an exponential? Log. I got to do log base 1.012. So I got log base 1.012 of 2 equals x. And so that'll be log of 2 divided by log of 1.012. And it gives me 58.108 quarters of a year. Now, if I ask you how old you are, and you tell me that you're 47 quarters of a year old, I'm going to think you're a very strange person, right? You don't usually answer questions that way. In fact, on the quiz, I'll try to make sure that I say, how many years will it take for his money to double instead of how long? Because technically, this is an okay answer because you're telling me quarters of a year. But I'd really like to switch this back to years, so what should I do? Divide it by 4. So I'll get 14.527 years. So no matter how much money he had, it would take 14.527 years for it to double. So if he put only $7 in this account, it would take him that long. If he had $1 million, after 14.527 years, he'd have $2 million. So if you find one that's missing a starting value and it's asking how long it takes them to double, triple, quadruple, just make up a starting value for that. It depends on whether the answer is yes, but it does depend on whether it's like quarterly or monthly, or so it would change according to that. But if and the interest rate causes it to change. But for like a very specific situation where you've got this interest rate and this, it will always be that same amount of time for that specific situation. Yes, and I would choose one. I usually do whenever I do these problems. So I usually would do it like this, 1 times 1.012 to the x, and whenever you double 1, you get 2, because it makes it really easy because you don't even really have to do the division. That 1 just goes away and just rewrite it. So I usually do choose 1. But if it bothers you that Alfredo only has $1, you can give him more money if you want. And that he's putting this $1 in an account. Yeah. Well, I mean, I made this problem when I had Alfredo in class. Okay. All right. So there is another type of formula that we can use that's different than a times b to the x. It is the PERT formula. If you were old like me, you would remember commercials on TV about the PERT shampoo. I don't know if they still make it or sell it. Shampoo and conditioner in one. It was innovative technology for the time. But the PERT formula is what we're going to use if we have continuous growth or decay. So if I want you to use the PERT formula, I will generally use the word continuous somewhere in the problem. So I will say it grows continually at a rate of. So I will use the word in the problem, because if I don't use the word continually, you could really do it either way. But I will try to use the word continuous in the problem if I want you to use this formula. Continuous growth, Particularly, we find that it works well for modeling things that are like in the natural environment, such as population growth and stuff like that. It definitely can work well for some like scientific applications as well. So, for this equation, P is your principal amount. E is a set value. It's in your calculator. You're going to use that there. We've talked about it. The rate, I should have put this as well as a decimal. Now, for the PERT formula, the rate is just a straight rate. We do not add one to it or take one away from it. Okay? It's just, so if our rate is 5%, we just put 0.05 there. And then T is going to be whatever time you're dealing with. Okay, so Walter just got a job as a high school chemistry teacher. His first year, he lives with his parents, and he saves $20,000. He puts the money in an account that earns 6.75% interest compounded continuously. If he leaves the money in the account without making any deposits or withdrawals, how much money will be in the account when he retires 29 years from now? Okay, so if any of you, well, even if you're not going to be a teacher, whatever you're going to do, first year out of college, if you, can live cheaply, put away $20,000. Stick it in an account that gets pretty good interest. We want to see how much we're going to have when we retire. This is a really good practice to do. Don't go buy a car like I did. Well, you could still, depending on where you live and what you do, you could probably still save up some money if you just don't splurge on stuff. But
So like as soon as you
yes. It wasn't a fancy car. It was just a Corolla, but it was new, so it was still expensive. I wouldn't really do that again. But I did. Huh? I had a car, but it was starting to have like a few problems. I probably should have just I should have just waited till it quit on me, probably. But I'm also not totally for buying brand new cars anymore. I generally like to buy one that's a couple years old and has like 40,000 miles on it, and it's not got that sticker price, on it still. Even though my husband's truck was new, but I don't love buying brand new cars, but I did then. So we're gonna save up this money. So our initial amount is $20,000. Okay, it is compounded continuously here. So that tells us to use the PERT formula, not 1 plus the rate. So 20,000 E to the rate times time. That rate needs to be a decimal. So 0.0675 times 29. And we are going to just plug that in. For the PERT formula, you do not add 1 to your rate. If we were just using annual interest rate formula, we would do, but this is not compounded annually, it's compounded continuously. So we got to use this formula. We do not add 1 to the rate, but that's a good question because it feels like we should, right? Okay, we're just going to type it in. He would have $141,000, $632.02 in his account. And then, whenever he got lung cancer, he wouldn't have to make meth to have money for his family left. After that, this is the storyline of Breaking Bad, if you have not watched it. I'm not suggesting you get into Breaking Bad. It's dark. It's not a nice show, but I love The Office.
I mean, Breaking Bad sucks you in, but it's awful. But I do love The Office. I watched The Office whenever it was like coming out and you had to watch it on TV. I loved it. Like every Thursday we had to be there in front of the TV to watch it. That was what I had. Probably like I know it was out by like 06. Yeah. I was in college.
And also depends on which one you're talking about, because there's two. One's English. That was
Yeah,
the first one.
it was first, so it was before that. Yeah, so I've never really watched it. All right, I'm not going to do this one. I want to skip to the other notes
Not Jeffrey.
because we need to do some decay. We're just going to skip and do a few of these. It's 4 or 5, I think. I think. It's probably going to be 9 because I'm going to take that in behavior one off. We'll see. Okay, let's look at this one. Actually, let me see. I want to do... Is there a... Oh, let's start with this one. All right, so if you're like me, you get out of college and you buy a new car. My car did not cost $43,000. It was just a Corolla, so it was much cheaper than that. But you get out of school, you buy a brand new car, and as soon as you buy that car, it's going to start depreciating. Unless it is a classic car and you just stick it in the garage and rub on it, it is not going to increase in value, right? Although we are in some really strange times where cars did actually jump up in value for a little bit because there was a shortage. But in general, normal times, cars do not increase in value. As soon as you buy that car, it's going to start depreciating. So I want to know, if I have the situation, how long will it take for the car to be worth less than half of its initial cost? So this doesn't say anything about continuous. We're not going to use the PERT formula here. So we've got $43,000. And then for this rate right here, since it is depreciating, we're losing value. Okay? I need to take that 11%, which is 0.11, and I'm subtracting it from 1. Right? So when we're depreciating, we've got to do 1 minus the rate, not 1 plus the rate. So we'll get 0.89 whenever we do that. So that's our number that goes right here. And this is a how long problem, so I don't know the time. The exponent there is always your time. So I'm going to have to put an X right there. I don't know how long it's going to take. So, I need to know how long it's going to take for the car to be worth less than half of its initial cost. So I need to find half of its initial cost, right? 43,000 divided by 2 is going to give us 21.5. And I'm going to put that over here. I want to know when it costs $21,500, or be worth $21,500. This is a similar problem to the how long will it take for Alfredo's money to double, except for they did actually give us the initial value here, and we're dealing with decay.
So even though it's like how much would it be less than that, it's still...
Yeah, so this is going to give us the exact time when it's worth half, so any time after this would be our answer. Okay? All right, so 21,500 divided by 43,000 should give us half, right? How do we solve this? Log with a base of 0.89. So we've got log base 0.89 of 0.5. So log of 0.5 divided by log of 0.89 is going to give us 5.948. Yes. And that is years. So almost 6 years for it to be worth half, which is actually not that bad for a car. That is decent.
How many miles do we put on those?
If you drive like I do and put like 25,000 a year on a car, then 150,000 is about wore out. Now, it also, car values do depend on condition a lot. So if you were driving a lot of miles, like because I would probably have 150,000 miles on this car, it might actually depreciate faster. So that would affect that rate that you're given there. Whereas if you only drive it 5,000 miles a year, that rate, that 11% per year, would probably actually be lower, you know, in that case. So, yeah. So we're running constantly. All right. Now we need to look. Let's go back to example 5. All right, this is our last one that we're going to look at. Half-life. All right, so science. Okay. Half-life of a substance is the amount of time it takes for half of the original amount of a substance to decay. Half-life is used very often in medicine and carbon dating are big things that you see this in. Other science-related things as well. But if you have the half-life of a medicine, that shouldn't say medicine substance. I think I was going to use one or the other. Let's say medicine is 4 hours. How much medicine will remain in the bloodstream 13 hours after 13 hours if the initial dose was 800 milligrams? So you take 800 milligrams of, let's say, ibuprofen, which is twice what you're supposed to take. So don't do that unless the doctor said that you should have. So you take 800 milligrams, and every 4 hours, it's going to be cut in half. So if you think about a table, after 0 hours, you're going to have 800. Well, then after, if we're thinking about half-lives, so after 1 half-life, you'll have 400. After 2 half-lives, you'll only have 200. After 3 half-lives, you'll have 100. So your body is processing that medicine in that rate. So it's being cut in half each time, so we're going to use half as our rate. And we're going to have an X, or actually, it's 13 hours, but our X right here is not in hours. It is number of half-lives. Right, because it doesn't get cut in half every hour. It gets cut in half every 4 hours. So, in 13 hours, how many half-lives would we have? 3.25. Okay, we're just going to take 13 hours and divide it by every 4 hours, because every 4 hours it's cutting in half, and that's going to give us 3.25. So to go from your actual amount of time to just the number of half-lives, we're just going to divide by whatever the length of that half-life is, which changes with everything that you're dealing with. So now we can just type in 800 times 0.5 to the 3.25. If it asks how long, you're going to set it equal to something because it's going to be like that X that you're adding, looking for there. If it gives you the time, then you usually just start plugging in. Okay, so we'll have 84.089. I'm just going to keep some extra decimal places there so I don't have to round that off because it's difficult. But if you did, I guess it'd be 84.89.
milligrams. Okay, yes.
Is there a formula for this?
If you see half-life, it's just basically A times 1/2 to the X power here. A being your starting value, and X being number of half-lives. Yes, possibly. I mean, I can't remember what I put on there and did not just right now, but it's definitely up for being on there. All right. So, this assignment here. Okay, has some practice problems with this. It has 12 questions. I will allow you 3 skips on this homework. So you can skip 3 problems if there's something you're stuck on. So you have to do 9 of them. If you want to do all of them, that's great and wonderful. The key is on Canvas. I think everybody's in Canvas now. So I shouldn't have to send out emails. It should be there. So you may skip 3, so you gotta have 9 of these tomorrow. Although, doing all of them is good practice. Yes, I do have smart breakfast in the morning. Hopefully it'll be a little less crowded than it was this morning. There's too many people here this morning, I couldn't get to everybody. 7:50.